Hi, I'm Nick Arston. I'm a mentor for Team 2220 Blue Twilight, an FRC team out of Eagan, Minnesota. Um, Tonight we're going to talk a little bit about basic linkages. Before we get into that, though, I want to talk a little bit about what a linkage is. Um, Linkage is a very broad term when you start looking around. It can really refer to an entire group of things. Broadly speaking, though, a mechanical linkage is any set of bodies assembled together to manage their forces and movement, a definition that I borrowed shamelessly off of Wikipedia. Um, One of the key bits of this is that linkages can be stationary or mobile. They can be in 2 dimensions or they can be in 3 dimensions. They're just an extremely broad category of things. In broad terms, though, when we refer to linkages in FRC, we're usually referring to mobile planar linkages, so stuff that exists on one plane or in 2 dimensions effectively. Um, and yeah, many common linkages in FRC have more common names. You might just call it an arm or a 4-bar arm or a scissor lift, right? These are all linkages or combinations of linkages. Um, for the purposes of this video, though, we're going to talk about what I would call interesting linkages. So linkages that are not obvious or don't have simplifying characteristics um, in terms of, oh, all of our bars are parallel to each other um, or anything like that. And we're going to talk about a general method of creating these linkages in a part studio on Onshape and then assembling them. And then taking those into an assembly and assembling them in a nice way that will accommodate future changes and stuff like that. In future videos, we'll talk about specific linkages, stuff like creating an over-center linkage or particular kinds of 4-bar linkages, and how do you actuate those really nicely in an FRC environment. Um, so whenever I'm sketching a linkage, what I like to start with is our core geometry. So in these terms, our core geometry is stuff like our start and end position and where we want our like mounting points to be. So I'm going to be designing in this a linkage that isn't really like, it doesn't have anything really attached to it. It's there. Um, it's there to it's to show the technique, right? I'm not going to be designing explicitly like something that is a linkage for an intake or whatever. This is just to show that technique, and I want to make that clear right off the bat. So we're going to give these some dimensions. Um, and something like this. So that's that dimension first. Make these guys equal. This is one of the key things about really doing language as well is about using equality and using stuff geometric constraints in Onshape to efficiently do things. So this is going to be one of our endpoints. It's going to be what I'll call our end position. End versus start is really arbitrary. You might notice that this looks a little bit similar to something. Let's actually put that up like 9 inches, 2 inches in. So this is our start position. This is our end position. And this is going to be where we want our pivots to be. Okay, so let's go through those bars again. End position, start position, pivot points. And just make this a little bit, move these up a little bit. Okay, and start pivot. Okay, this is going to be our master sketch because it's what's going to define all the rest of the sketches. Or I would also maybe name this core geometry. You can call it all sorts of things. So this next sketch is going to be our linkage sketch. So you'll notice, so in some cases you could simplify this and you could say, okay, I'm just gonna take out this bar and, in this case, I can't just have a bar that pivots on this point and goes from here to here. That's just not a thing. If I want it to be there, it would have to exist in a different place, which is another valid way to do this if you don't care about the exact pivot to position. Right? This is an entire set of solutions for a single bar on there that works. But in this case, we can't actually do that. So instead, what we're going to do, and this is effectively going to be a what we call 4-bar linkage, or an asymmetric 4-bar linkage. What we're going to do is we're going to define a couple of points out here. And what these points are is going to be what the arms that, whatever the bars that go from here to here, this is what's going to define those. And it's important that these don't have really any constraints to start with, because they're going to be completely driven by what our needs are. So important bit about these is that they end on each of those points and that they are equal. So we'll take these and we'll make the equivalent things equal. So now you can notice, right, since this is a triangle, those correspond to each other. All right. So now we have a couple of triangles and we have a couple of points. So this will let us do essentially an arbitrary linkage from here, an arbitrary set of things. So I want that to be in here, this to be in here. I want another circle. We'll go here, and it'll also be there. And this gives us a large group of potential solutions to our thing. And the way you can think about this is essentially these circles represent the range of movement of a bar that goes from this point to there. So I got one there, and I got one here, and one here. And this kind of looks like a mess if you don't know what you're looking at. But again, we got our base geometry. We've got our start position. We've got 2 points attached to that. And our end position, 2 points attached to that. And this is giving us a bunch of what it describes as valid linkages in this group. And what we'll want to do is we'll want to define these. And you can define these in a bunch of different ways, but typically you just need one thing to kind of lock things in place. So if I want that to be 9 inches, this to be 11, right? That's a little bit close to there, but it's fine. And then we have our core linkage geometry. And what this is roughly going to turn into is this is going to turn into a mounting plate down here, a bar here, and then a plate from here to these 2 points. We're going to sketch all 3 of those things. Now something interesting might be happening over here, which is that this bar, depending on how close these are, very well might interfere with this one, so we might have to do something interesting to deal with that. Okay, so I'm going to call this the linkage master. And we'll close that sketch. Now this is going to be our mounting plate sketch. And this is going to be real simple. We're going to take that. We're going to add a couple of points. In FRC, it's a fairly safe bet that you're going to be okay with a 1 1/8 inch hole. Also a fairly safe bet that you're going to be attaching to a 2x1. So that. And then we'll want to set these. Make some tangencies. And we've got that mounting plate. I can add a quarter inch something or other. All right. So got a mounting plate. Next step here is going to be creating these linkage bars. In this case, we're going to make the assumption that we're going to decide that those are going to be planar with each other. So they're going to be in line with each other. You don't necessarily need the bars of your linkage to be in the same plane. In fact, it can be really useful for them to not to let them cross over or do similar actions. But for our purposes, we're going to say that they are. They are roughly. Maybe we need a little bit of a gap here because we wanted a bushing. And that's like a 1 inch thing, but who really cares? This is an example. So we're going to borrow those. I'm going to say, all right, we got those. These are all the same, so we'll let them be the same. And noticed here, I'm not going to be able to just make something that goes straight through that. It's not going to work. I'm going to have to do something a little bit different there. This one, I'm just going to make it a slot around there. And then equal to these, it's just going to be a really simple bar. This one, though, we're going to need to be a little bit clever and use something like an arc. We'll take that and make it tangent here. This isn't totally necessary. So the other way to do this is instead of using that arc, what we could do is really small offset circle here, say 32nd of an inch. And center point arc. This point to that point. Make sure everything is tangent. We want to be tangent. So that's probably good. And then if I want to make sure that, like, say, actually, undo that. Let's say we want to make sure that we have at least an inch distance here. Or a whatever this is. This is a 1/8 inch plus a 1/2 inch, so 65. Okay. And goes down there. Make some of this stuff tangent. Then we have our 2 bars. We can just extrude those. Also going to be a 1/4 inch something or other. Linkage bars. Cool stuff. I'll move this in just so it's not something wild out there. 1/8 inch or something is probably where it really wants to be. And then draw another one in the front. And this one is going to be this bit. I hope that walking through this makes it a little bit clearer what's going on in those sketches, right? What we're doing is we're defining the core geometry that we're going to use to define this linkage. It doesn't necessarily make sense in your head until you've done it a few times. So hopefully seeing it worked out is helpful to you. And then we're going to make a bunch of stuff tangent. And I really emphasize starting with that core geometry first. The reason that you want to always start with the core geometry first is because your linkage exists to solve a purpose. And if you're careful about how you construct all that beginning geometry, you can make sure that it does, you aren't compromising on that purpose to meet something else. So now we've got our all of our parts, and we can take those into an assembly. I'm going to name these first to make it a little bit easier on myself. And then we can insert those all into here. Since things are going to be, this is the mounted plate, we can fix this. And the rest of these are going to be revolute mates on that. So, and obviously if I had a bearing or some sort of bushing there, I wouldn't necessarily do it that way. So now I have 3 of them, right? And I have, And this one is going to get a different kind of mate. So I used a revolute mate there. Revolute mate only allows something to rotate on an axis. For this last one, I'm going to use a cylindrical mate. The reason I'm going to use a cylindrical mate is because um, that does sufficiently fully constrain everything in here. Um, and if you try to revolute mate, you'll actually over constrain it because you have potentially things that aren't lined up that are trying to be lined up. It'll might work in this particular case, but it wouldn't work if these things were offset at different in different ways or anything like that. So now we have roughly a linkage, and we can see that if I'm careful, I can move it into my desired positions, right? But I can still do something like that, like lock it somewhere back here, right, where it's in an impossible position. To avoid that, what we can do is I can measure the angle here. And one of the things about how Onshape mate connectors work is that they'll always start the things in, if you sketch everything up like this, it'll start that mate connector in a zeroed position that lines up with this. But that means I can copy paste that 42 degrees and I can see, okay, so if I move this out, so if I'm back here in its original position, I can take a look at this and see that it's in roughly at 360 degrees. And when I move this out, it's at roughly 20 degrees, right? So what I can do is I can edit this. I can set limits. I can set a limit of 0 degrees here, a maximum of that 42.7. And then I can't move it extra, but I can move it exactly to those positions that we wanted. All right, I hope that that was a useful run through of how I sketch up linkages, especially 4-bars, which are what I oftentimes find myself designing for FRC. Thank you. Again, we'll have some future videos out talking about some other specific linkages and designing some linkages in particular context for an FRC. So like taking this and designing an intake or something like that, an intake linkage. Thanks and see you next time.